Okay, so we've really started looking at the unit circle and how it works. And you could look, you could memorize anything. You could memorize every single value on the unit circle for every single angle. Or you could just memorize none of it and understand how to work it. And then there's everything in between. So you just got to figure out what level of stuff are you willing to memorize and what level of stuff you're going to work out. Sorry, you're going to work out by just understanding or remembering how things work. So, in the effort of giving you more stuff that you can use as a tool, like if you want to memorize these things, these would be helpful to cut out some of the understanding and make it a little faster. And we'll kind of settle in as we go as to like what level of information you want to memorize. So we're going to build this trig value chart, and what's recommended by me is to know these three columns for these reference angles. Those are really the ones that we'll want to know. All right, so we're going to go through that. And I'm not going to re-explain where each one comes from. You have your unit circle. We've already done that. We're just going to write down the values. So the sine value for 0 degrees, we're at 0. Or if we did one full rotation at 360, and then that would also be in radians, 0 and 2 pi. That's the 0.10 on the unit circle. So the sine coordinate, the sine value, which is the y coordinate, is 0. The cosine value is 1. Tangent is sine divided by cosine, so that value is also 0. So I'm going to erase that part. Okay. So then what we're going to do is cosecant, knowing that they're the reciprocal is the key here. And the reason I say we don't want to memorize these is it's pretty easy to just flip the fraction of the other one. So reciprocal means flip the fraction. So we're going to think in terms of a fraction, we'll think of 0 as 0 over 1. We'll think of 1 as 1 over 1 and 0 as 0 over 1. So cosecant at 0 is the reciprocal of sine. So if I flip it, it is now 1 over 0, and that's undefined. We cannot divide by 0. If we flip over secant, secant is if we flip over cosine. So 1 over 1 flip just becomes 1 over 1 again. So that's just 1. And then cotangent is the reciprocal of tangent. So again, if we flip 0 over 1, we get 1 over 0. So we end up getting undefined. All right. Now let's do our 30-degree angle. The sine value at 30 degrees, again, you're going to get that off your unit circle. I'm not going to talk about how we built it. We've been doing that. It's 1/2. The cosine of 30 is going to be root 3 over 2. The tangent of 30 is now going to be, again, we can work it out and do sine over cosine. So I'm going to show you working out this one quickly. Sine is 1/2 over cosine is root 3 over 2. You might not want to write this down. It's up to you. Then I do 1/2 times the reciprocal. Instead of dividing by that, I multiply by its reciprocal. The 2's cancel. I get 1 over root 3. But I can't have a square root in the denominator. So now I want to rationalize by 1 over root 3. I'm going to get a little bit bigger pencil. And when I rationalize 1 over root 3, I get root 3 over 3. Now doing the reciprocals, cosecant is the reciprocal of sine. So if I flip 1/2, I get 2. Secant is the reciprocal of cosine, so I'm going to get 2 over root 3. But again, I can't have root 3. I can't have a root. Sorry. I can't have a root in the denominator, so I multiply by root 3 on top and bottom to rationalize it. I'm not going to work out all the math on that. You can do that on your own to confirm. It's going to be 2 root 3 over 3. And then cotangent is the reciprocal of tangent. So if I flip that, I get 3 over root 3. And again, I have to rationalize by multiplying the top and bottom by root 3 over root 3. So when I work that out and simplify, that becomes root 3. Again, I really kind of only want to memorize these, and it's easy enough to flip those. That's where I end up doing it. Like when I was in your seat, I would know the reference angles for 30. That means 0, 30, 45, 60, quadrant 1. I would know my quadrant 1 angles, and then if I needed my reciprocals, I would just flip those after the fact and simplify. All right, so I'm going to go a little faster through the table since we're pulling these off of our unit circle. So this one's going to be root 2 over 2 because this is our 45-degree angle. Root 2 over 2. When I make tangent, I divide those, and I get 1. And then when I take the reciprocals of all of those and rationalize the denominator for the 45, I should get root 2, and 1. And you should be able to work those out on your own. So let's go for 60 degrees. Off the unit circle, we get root 3 over 2, and we get 1/2. I'm going to ask you to pause the video here and figure out the rest of the 60-degree ones by taking the reciprocals and rationalizing and all that stuff. Tangent, first you do right sine over cosine and simplify. So I'm going to ask you to pause the video and do that. Okay, welcome back. Let's see if you got them right. So we've got root 3, 2 root 3 over 3, 2, and root 3 over 3 for our 60 degrees. Let's move on to 90 degrees. Now this one happens to be right on the axis, so it's a little easier. That point there is 0, 1. So the cosine value is 0 and the sine value is 1. And then we start building off of that. So tangent is the sine divided by cosine, so 1 divided by 0 is undefined because we can't divide by 0. You can pause the video and find the reciprocals. Okay, welcome back. So the cosecant is going to be the reciprocal of sine. And so sine would have been, if it's 1, we're kind of thinking of it as 1 over 1. So then that's still going to be 1 when we flip it. 90 is undefined because you can't divide by 0 after you flip your cosine. And then when we flip our tangent, we get our cotangent, and that's going to be 0 because we're going to think of undefined as 1 over 0. So when we flip undefined, we end up getting 0 over 1. That's how we think about those. 180, that's going to be this angle right here. So that's going to be something similar to what we just did, but the coordinates are now going to be negative 1, 0. So I want you to pause the video and fill out this row. Okay, welcome back. You'll get 0, negative 1, 0, undefined, negative 1, undefined. And if you have any questions on any of these, you need to ask me in class when we're doing practice. You can say, hey, I didn't understand this part in the notes, and I'll sit and work with you. Okay? 270 happens to be this angle down here, so that's going to be 0, negative 1 for our coordinates. So pause the video and fill out that row. Okay, welcome back. It should be negative 1, 0, undefined, negative 1, undefined, and 0. All right, so these are all from the unit circle. Really, these are the ones you need to know, and we can get the other ones from flipping those values. That's really the way to do it. So let's try a couple. So if I evaluate the sine of 5 pi over 4, first off, what I want to know is what is its reference angle? Whoops. That's sort of step one. What I mean by that is which angle is it the same as in quadrant 1? When it's in radians with pi, that's pretty easy because it's really just going to be that denominator. The reference angle is pi over 4. So now all I need to do is that's step 1. What's its reference angle? The reference angle is pi over 4. So step 2 is then to evaluate sine of that reference angle. So here's where the memorization comes in. If you memorize the chart for quadrant 1, we know that the sine of pi over 4 is root 2 over 2. Then step 3 is you have to go back to your original angle, 5 pi over 4, and figure out what quadrant is it in. Because all the reference angles, all the pi over 4 reference angles will have this as their sine value. Some will be positive and some will be negative. And the positive or negative is determined by what quadrant it is in. So that will tell us if we have to make it positive or negative. Here's what I mean. Pi over 4, our reference angle is here. If we look at all the other pi over 4 angles, it's these 4. So they're all going to have the same sine value and actually cosine value. They're all going to be root 2 over 2. For both values. So this is why we say reference angle. If the solid green one is the reference angle, any one of these, right, if I do 3 pi over 4, 5 pi over 4, or 7 pi over 4, they all go back to the reference angle pi over 4. I just got to decide the signs. So if both of these are positive, over here the x is negative, but the y is positive. In this quadrant, the x and the y are negative. In this quadrant, the x is positive and the y is negative. All right, so I have to decide what quadrant is, what was the original question? 5 pi over 4. So I see, here's my 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, and then 5 pi over 4. So it's in quadrant 3 where they're both negative, so the sine and the cosine are negative. So it's in quadrant 3, which means the sine of 5 pi over 4 is equal to negative root 2 over 2. All right, let's try this one. Tangent of 4 pi over 3. So I know that my reference angle is pi over 3. So now I want to evaluate tangent of pi over 3. That's in quadrant 1. Reference angle means quad 1. Now you can try to think through that, or if you have that chart we just did memorized, pi over 3 was our 60-degree angle, and tangent was root 3 after we did all our rationalization or whatever we needed to do. All right? Now I want to check what quadrant is our original angle in to decide if that's going to be negative or positive. So 4 pi over 3, if I do my pi over 3s, I got this one. We kind of skip over the axes. 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3. It's in quadrant 3 again. Both the sine and cosine are negative. So remember, tangent is sine divided by cosine. So in quadrant 3, the tangent is always positive. So we're going to remember that as well. We know that tangent is positive in quadrant 1 and tangent is positive in quadrant 3. Tangent's going to be negative in 2 and 4. So since it's in quadrant 3, I confirm that it's a positive value. Whoops, I should write this all out. So the tangent of our original angle, 5 pi over, it was 4 pi over 3, sorry. 4 pi over 3 is going to be equal to positive root 3. Okay? We've got two more here, cosecant and cotangent. So cosecant of 5 pi over 3, step 1, what's the reference angle? So we'll say reference is pi over 3. So then I evaluate the reference angle, the trig function at the reference angle, the cosecant of pi over 3. Okay, now here's the one that gets a little tricky. I don't memorize the cosecants. Remember on the table I said just memorize the first 3. But in pi over 3, cosecant is this guy right here. If you want to memorize that, I think it's easier just remember what sine is and then flip it and then do that math. So if the sine is root 3 over 2, you flip it, you get 2 over root 3. So how to end up with this crazy fraction? I had to rationalize the denominator. So it worked out to be 2 root 3 over 3. And now I just got to decide what quadrant is it in so I can decide if it's positive or negative. So the original angle was 5 pi over 3. So if I do my pi over 3s, I ignore the 90 because these are the 60s, right? So 1, 2, 3 pi over 3, 4 pi over 3, 5 pi over 3. So 5 pi over 3 is in quadrant 4. So it's in quadrant 4. And cosecant is the reciprocal of sine. So it's going to be like 1 over sine. And if sine in quadrant 4 is negative, because quadrant 4 is positive negative, so I have 1 over a negative number, it's going to be a negative number. So it's going to be negative 2 root 3 over 3. That's because sine is negative in quadrant 4, and cosecant is the reciprocal of sine, so it's also negative. Okay, last one, cotangent 11 pi over 6 is what we're trying to evaluate. So 1, our reference angle, back in quadrant 1, is going to be pi over 6. If we evaluate the trig function at our reference angle, we start there. So I know cotangent of pi over 6, cotangent pi over 6 is right here. Again, you can memorize cotangent, or you could have memorized tangent and flipped it and rationalized to get there. So instead, you could have memorized this and flipped it. Maybe you don't even want to memorize tangent. Then you would just memorize these two guys, the sine and the cosine, and you can build tangent by doing sine divided by cosine. Then when you get tangent, you could flip it. Or you can understand it's already flipped, so think of cotangent as cosine of theta divided by sine of theta, if you don't want to memorize it and you don't want to memorize tangent. So I could have done root 3 over 2 divided by 1 over 2 and simplify that, and you'll get root 3. Instead of dividing by 1/2, you multiply by the reciprocal and you get root 3. All right, so any way that you do that, you get root 3 for cotangent of pi over 6. And then I need to know what quadrant is my original angle in. 11 pi over 6. So we got our pi over 6s. So we got 1 pi over 6, 2 pi over 6, 3, 4, 5. So 1, 2, 3, 4, 5, 6. Put my little arrows as I count. Then I got 7, 8, 9, 10, 11, and we're 1 away. So I should have drawn that a little better. 11 pi over 6. We're 1 away from a full rotation. So honestly, when I do like 11 pi over 6, I don't count. I just know that 12 pi over 6 is really 2 pi, right? So we're 1 step away from a full rotation on the 30-degree angle. So anyway, that puts us in quadrant 4. Cotangent is related to tangent, and we know tangent is positive in quadrants 1 and 3 and negative in 1 and 4. So then cotangent is also going to be negative. So it's going to be negative root 3.